Hello dear students, please observe this question. It is asked in an examination, board examination. Use Kirchhoff's rule to determine the potential difference between points A and D when no current flows in the arm BE of the electrical network shown in the figure. We have to use Kirchhoff's rule to determine the potential difference between the point A and D. Point A and D when no current flows in the arm BE. This is the BE arm. There is no current in this arm. Then we have to find the potential difference between AD. So always it is not necessary to use the Kirchhoff equations. Here we see from A to B, if we are going, then there is a drop in the potential because this plate is positive, this is negative, and then we are going from this way, this is positive and then negative, then there is a potential drop. There is no current in this resistance, it means there is no potential difference over it, and then we will go from E to D, and then we can write the solution. So we can write VA and then minus potential of 6 volt, and then this path is again minus 3 volt, and there is no drop, and then we will come here, so that is, this is equal to VD. So this becomes VA minus VD is equal to 9 volt. So that is the value of potential VAD. So this is the answer. The potential difference is 9 volt. But if somebody want to find the potential by some other method using Kirchhoff rule, we can go at the D by this A to F and E and this point, or we can go by this to D, and we will get the same answer. Now let us use the Kirchhoff rule in this loop so that we can get the value of current here. So in this question, if there is no current in this line, then it means there is a current here I, and the same current will go on the same this line, and it will be flowing as on this loop. There will be no current in this line. Let us apply Kirchhoff's loop rule on this loop. We will not go here because this R is unknown in the question. We will go on this line because there is no current in this line. So from VA we go in this line, there is a current, so it will be certainly flowing from high to low potential. So this is drop of potential 2 into current, and then from here to here this is negative to positive. See the rise in the potential of plus 1 volt, and then the same current is flowing in this way. It means this is positive and this is negative. There is a potential drop, that is minus of 3 into current I. Same current I is flowing in this line, and then here there is no current, there is no drop, and then from minus to positive this becomes a rise in the potential. So this is plus 3 volt, and from here we will come to B, and from B minus to plus. So this is again a rise in the potential of this 6 volt, and then we will reach to A. So that is equal to the potential of A. So in potential of A we have done these many changes, and after these changes we have again reached to the same point A. So this VA and this changes and then is equal to VA. So now we can write this VA and VA cancels, and this becomes minus 2I plus 1 minus 3I plus 9 is equal to 0. So this gives equal to, this is minus 5I is equal to 10, and so the current is 2 ampere. So 2 ampere current is flowing, and now we can move to find the potential of D on this part. let us go on this line. So from BA we will go here, then there will be a drop in the potential -2 into current, that is 2 volt, and then rise of +1 volt, and then fall of potential 3 into current 2, and then here this equal to VD. We have reached to VD. From A there are changes, and then we have reached equal to the potential of VD. So I need VA minus VD. So VA and that minus VD is equal to, we will write all these things, 3 to the 6 positive, and 2 to the 4, and 4 and 1 less 3, and so this is positive 3. So this is VAD potential between AD is equal to 9 volts. So this is by using Kirchhoff's rule. This is another question which is asked in the board examination. It is asked as, in the given circuit, assuming point A to be at 0 potential, use Kirchhoff's rule to determine the potential at B. So in this circuit, assuming this point at 0 potential, we have to find potential at B. So not necessarily we will use the Kirchhoff rule. In this question, 4 ampere current is coming in this direction. At this junction we apply the junction rule, Kirchhoff rule. So out of that 4, 1 is going in this direction. So certainly in this direction 3 ampere current will be passing. And so 4 ampere is in this direction. It means this is 3 ampere here, and this 1 ampere is coming on this line. And then they join here to make a current of 4 ampere. So we have to find potential at B. So this potential at A, and then in this direction, suppose we will go on this line. So this is minus and plus, so rise in the potential. There is a current here in this direction. This is minus, this should be positive. So VA, and then a rise in the potential of 3 volt, and then this direction again there is a rise of potential of 3 into 2, that is V is equal to IR, potential drop. And then we will come from this line here. So this is a positive and negative. So there is a drop in the potential of -6 volt, and then we will reach to the point VB. So VA and minus this one drop, and then there is a rise in the potential, and again drop in the potential. We have reached to this height from this low. Now this VA has been given 0. So certainly we will be getting 3 to the 6 and 6 cancel. This is 3 only, is equal to potential of B. This will be 3 volt potential. In this question, calculate the value of resistance R in the circuit shown in the figure, so that the current in the circuit is 0.2 ampere. The current is 0.2 ampere. What would be the potential difference between point BE? So BE, this is a B and this is E. What is the potential difference between BE? Calculate the value of the resistance R in the circuit, so that the current in this circuit is 0.2 ampere. So we have to find the value of R and this potential VBE is how much. This is the question. Here we will need to reduce this circuit, and we find the so many series and parallel combinations are there. These 5 and 10 are in series with each other. So 5 and 10 are in series, they will make a resistance of 15 ohm, and then this line is in parallel to this one. Why? Because if any current is coming in this direction, it has to go in this line and then it in this line. So they are parallel, meeting at this point. So this value, that is 15 ohm, is parallel to this 10 ohm. So whose value will be 15, 10 upon 15 plus 10. So this becomes 150 by 25, 6 ohm. So this resistance is 6 ohm. Now this 6 is in parallel to this 30 ohm, because at this point the current is going in this line, and then the same current is coming in this line and then meeting here. So and between these 2 points, this line and this will be in parallel. So now this 30 is in parallel to 6. 30 in parallel to 6 will give a resistance of 30 into 6 upon 30 plus 6. So 30 into 6 upon 36, that is 6 ja 36, and then it is 5 ohm. So we have reduced the circuit up to this much. So that is a 5 ohm resistance. We will draw a new circuit now. So this is the reduced circuit in which between B and E a net value of resistance 5 ohm has been connected, and all other things here 0.2 ampere current is coming, and then it is going to the same 5 volt, and everything is same as earlier. We can apply the rules to find, but here directly we can find the potential difference between BE. Let us go from B. At this point potential is VB, and then the current is going downward. It means this is positive, this is negative. So there is a drop in the potential of minus 5 into current. The current is certainly 0.2 ampere, and then we have reached to VE, that is the potential at E. So potential VBE, VB minus BE would be equal to, this is 1. So VBE potential is equal to 1 volt. In 1 year, this question was asked: use Kirchhoff's rule and calculate the current in the arm AC. This current we have to find in AC arm of this given circuit. In that examination, this direction of current and I1 and I2 was given. So we cannot change this I1 and I2, otherwise we can take our own current. So now how to solve such a question? So here we have to use the Kirchhoff rule certainly. Let us select a loop, that is AE, this line, this loop. We select AEFCA and start from any point. Let it is VA, potential at VA, and we will go in this line. So this is a drop of potential because current is in that direction. So 30 into current I1, and then F and C, and then from here to here, because minus and positive plate is here, so there is a rise of potential 40 volt, and then current is in this direction, so this would be positive and this will be negative, drop in the potential, that is equal to minus of this 40 into the current I1 plus I2, and then we will reach equal to the potential of A. So this is a completed loop. So now this is equal to how much? Minus 30 I1 plus 40 and minus 40 I1 minus 40 I2 is equal to 0, and that is, it is minus 70 I1 minus 40 I2 plus 40 is equal to 0. It is equation 1. So for two variables equations I1 and I2, we have to take another equation. So let us select another loop of this one, this outer loop. We will move on this line, like on this line we will move outer loop only, we will not think about this line. So this is a loop A, E, F, C, D, B, A, and let us write the value from any point. Let us it is VA, and then a drop of minus 30 into current I1, and then on this line the current direction is this one. This is the current, so this will be positive and this is negative. This is VA and then drop, and then in this direction minus to plus, so there is a rise. This is 20 into current is I2, and then plus to minus, this is drop, minus 80 volt, and then we have come to VA. So let us rearrange it. VA will cancel. This is minus 30 current plus 20 current I2 minus 80 is equal to 0. So here it is a 40 I2 and here it is a 20 I2. We multiply this equation by 2. So this is minus 60 I1 plus 40 I2 minus 160 is equal to 0. Let it is equation 2, and then we add these two equations. So this will be 7 and 6 130, and then 40 cancels, and then 40 and minus 160 120 is equal to 0. So this would give a current I1 is equal to how much? 12 by 13 ampere. So this is minus 12 by 13 ampere, and we have calculated the current I1. Then we will put its value in some equation 1 or 2, and we will get the value of desired current in this line. Thank you.